Welcome back, students. Dear students, in this session, I am going to explain the topic Second Law of Thermodynamics, that is Kelvin and Clausius statements. Let us see the Second Law of Thermodynamics. The first law of thermodynamics, which expresses the universal law of conservation and conservation of energy, is insufficient to determine in which direction thermodynamic process will proceed. On the basis of this law alone, one might attempt to build a perpetual motion machine of the second kind, that is, an engine whose working medium would accomplish a cycle, receiving energy from a single external body in the form of heat and delivering it completely to another external body in the form of work. The generalization of the results of numerous experiments has led to the conclusion that it is impossible to build a perpetual motion machine of the second kind. This conclusion is called the second law of thermodynamics. There are two classical statements known as the Kelvin-Planck statement, and the second one is Clausius statement. Dear students, the second law of thermodynamics reveals us that what percentage of heat can be converted into work. Let us see the statements. First one, Kelvin's statement. It is impossible to derive a continuous supply of energy by cooling a body below the coldest of its surroundings. I repeat, Kelvin statement. It states that it is impossible to derive a continuous supply of energy by cooling a body below the coldest of its surroundings. Can just refer the figure here, diagram, that is impossible engine. This is heat engine. Here this is hot reservoir which is at temperature T1. This is cold reservoir which is maintained at temperature T2. Here this is the diagram of heat engine that takes in energy from a hot reservoir and does an equivalent amount of work. It is impossible to construct such a perfect engine. Second statement, that is Clausius statement. It states that like this: it is impossible for a self-acting machine, unaided by any external agency, to transfer heat from a body at a lower temperature to a body at a higher temperature. That is, heat cannot by itself pass from a cold body to a hot body. Heat cannot by itself pass from a cold body to a hot body. Example for this one is refrigerator. See the second diagram here. This is schematic diagram of refrigerator. That means impossible heat pump. This one is, first diagram is impossible engine. This one is impossible heat pump. It consisting of heat reservoir, that is T1, and cold reservoir T2. This is schematic diagram of an impossible heat pump or refrigerator, that is one that takes in energy from a cold reservoir and expels an equivalent amount of energy to a hot reservoir without the input of energy by work. Without the input of energy by work. This is about the Clausius statement with an example of refrigerator. So, from this we find that heat cannot flow by itself from cold to hot body. So we have to do work to make this flow. So this statement can also be stated as perfect refrigerator is impossible. Let us see the application of second law of thermodynamics. It is refrigerator. A heat engine run in reverse is known as refrigerator. A refrigerator needs work to transfer heat from cold body to a hot body. If Q2 is the amount of heat removed from the cold body at the temperature T2 and Q1 is the amount of heat given to the hot body at a temperature T1, then the difference of heat energy is Q1 minus Q2 is the external work required to drive the refrigerator. Q1 minus Q2 is the external work required to drive the refrigerator. In a refrigerator, instead of efficiency, we use the term coefficient of performance, that is K, which is defined as coefficient of performance is equal to the ratio of desired output to the required input. Therefore, coefficient of performance is the ratio of heat removed from the cold body to the mechanical work required to operate the refrigerator. That is K equals Q2 upon Q1 minus Q2. Q1 minus Q2. Q2 is the heat removed from the cold body. Q1 minus Q2 is the work required to operate the refrigerator. In a perfect refrigerator, work done is equal to 0 and Q2 equals Q1. So, the coefficient of performance of perfect refrigerator is infinite. In an ordinary household refrigerator, the working substance is the liquid, that means freon, that circulated within the system. The cold body is the interior of the refrigerator and hot body is the room in which refrigerator is kept. Typical refrigerator have the coefficient for performance nearly around 5. This is about the second law of thermodynamics and its applications. Thank you.